Okay. So I'll record our meeting and then post that, but I will need people to attend, and I do need to take attendance for them to get credit for the class if you know anyone. So was that email clear enough? The email about meeting and how we want to proceed?
Yeah.
That was fine. Okay. And I realize that we might not catch someone. But okay. So should we talk astronomy for a bit?
Yeah.
Yeah. I know. It's kind of weird to jump in. All right. So what we should do too, just setting things up, is try out my my board. Can you see the word astro up there? Is that very clear?
Yeah. Yeah, that's clear.
Cool. Cool. Wait, Amanda's here.
Yeah.
Hi, Amanda. Yay. You made it.
Yeah.
You guys get points for just showing up, man.
Showing up.
That's a big part of success anyway, showing up. I don't know. It could be fun. A new venture into online teaching. All right, so I will recap. Let me make a note here. So you got the chat possibility down there. Has anybody got questions before I go about Zoom or about Canvas discussions?
When it comes to like going on to Zoom, are you gonna send us a link every single time, or is it gonna be this same link?
I think it's a different link. So
like an email or like a message on Canvas every single time we have a meeting?
Yeah. Is email okay?
Yeah, that's fine. I was just wondering because like for my other classes on the side, there's like a little thing where you press Zoom and then it'll just automatically take us there. So like this one is different because it's just a link. It's not like one of the under modules and all of that. It's not.
Yeah, we do have a Confer Zoom, and I'll play with.
When I clicked that, it just showed like it wasn't taking me to any videos. That's why I came on a little late, because I was trying to figure it out.
Ah, okay. Okay, cool. Good. Yeah, I'll play with that and see if I can make it simpler. So thanks. Let me make a note of that. Use Canvas link. All right. Yeah, I'll check with that. Sorted. All right, and then with the chat, let's see. That up there in case joins. Okay. Last we met, man. So we were talking about, I don't have. That's interesting. Things that I don't have. We were talking about 2 meetings for day and night. Do you guys have any questions about that? Get my head cut off. So we had 2 meetings. And let me know if you can't read. Sorry, year, day, moon cycle. That's what I want to say. And I've got the videos up for that too. And hopefully that's clear. Do you have any questions about those 2 meetings? Is that clear? Should I go over that quickly? You want me to go over that, or are we good?
Over what 2 meetings?
the 2 meanings for a year. So
Yeah, could you go over that?
yeah, and I'll do it kind of quickly since I've got the YouTube, and you can then ask me to illuminate any things that don't make sense. So choose my color for sun. I'll make a red sun. And again, let me know if you can't read this. We'll work this out. So for a year, we've got 2 meanings, and those 2 meanings come from what we see from Earth. Can you read that?
Yeah.
Yeah? Cool. Let's try green. And what we see from a spaceship, is that okay? Green's good?
Green's good.
Okay, cool. All right. So as far as a year goes, let's do year. For a year, we talk about a calendar. And the way you make a calendar from, this is all chapter 1, and a calendar was set initially by looking at sunrise and sunset. So we've got eat sandwich, and then we've got our paths. We have June 21st is, oh, I didn't even send you guys a happy spring. I'll send you guys a note about that. So it's going to rise not east, but to the north side of east, just as a quick review, on June 21st. And then it comes over, and I won't write everything down here because you've seen it and you've got it in the video, but ask me if you want me to write anything. So we got June 21st, and that sun is going to rise up, go the highest all year, and set the farthest north of west. And then each day, right near June 21st, it doesn't change very much, but it'll change July, August, and then September 21st about. It's going to rise up directly east, and sun will go not as high, and then sun will set directly west. So there's September 21st. And then September, October, November, December, around December 21st, it's going to rise up on the south side of east, the farthest all year, not go very high, and set here. We're going to come back to this too. So this ties into seasons, which we'll go into today too. And then after that, December, it's going to go January, February, and so this is also March. So this is both equinoxes, summer solstice. Summer leads into fall or autumn equinox, solstice, equinox, September, October, November, December. Then that starts winter, December, January, February, March, also the equinox, summer solstice, fall equinox, winter solstice, spring or vernal equinox, which we just started. So now we'll see, we were picky about it. Now that we've hit spring, it'll start rising more and more over here. It'll set more to the north side of west, kind of to the right of Mount Tam. And it'll be getting higher and higher, and our days will be getting longer and longer. And so, of course, we set that too at the calendar, so I'm kind of going into the season thing too. So for our calendar, we've got 365 days plus 1 day added to February every 4 years. And so we say, well, why do we do that? Why do we have a leap year? Is that okay? What do you think, guys?
You're lagging a little bit.
Oh, I am. Huh, interesting. Let's see, my connection's pretty good. What do you think? Is this okay? Yeah, can't see anything. Now it's blurry, lagging. Huh. Okay. Is it blurry, Tiffany? Is it blurry for you? You there, Tiffany?
Yeah, I'm here. Yeah, it's a little blurry.
So, I wonder how we want to do that. Is it the connection? Is it the lighting?
I think it might be the lighting.
The lighting? I got it. That worse or better?
Still blurry.
That's
I
interesting.
think it's the connection that's making it a little blurry. It's not like completely blurry, just like fuzzy.
Okay. And I don't know then, maybe, and it could be through Zoom because they're getting completely overloaded. Let's see, let me try something. We've got time to work this out anyway. If I come in here, does that get clear at all?
No, I'm pretty sure it's the connection.
Yeah, okay. Right, that's I figured. Okay, well I'll talk it through and see if this, okay, who can't, Samantha, you can't see anything?
It was really blurry for a second, but I can still hear you, so it's good.
Okay. Can you kind of see it?
Yeah, I can kind of see it.
Let me see if we've got another light here that I'll see about adjusting this. Is that any better? No difference?
Oh, you're frozen right now.
I'm frozen. This is a little chilly in here. How are we doing now?
Yeah, you're good.
Okay. All right. Yeah, I think it could be Zoom overload. We'll give it a shot. I'll see how the video comes out too. Okay, but do let me know because we've got time since I've got the full lectures on video and we'll continue to make fill in the gaps. We can struggle through this a little bit and answer your questions. So chime in any place you're not clear about, and I'll go over that again. So Seen from Earth is just chapter 1. It's a nice review, and so it lets us tie this together. A year is just a calendar year, 365 days, and we can see where sun rises, and that goes back to the same place in one cycle, one sun cycle or year, where it sets or how high it is around noon. So 365 days, but we do add that leap year. So we wonder, why is that happening? That's the question here. Why is it that sun rises and sets like this? All right, my dog has joined us. So let's take a look at from space. Oh, I could do this. That's interesting. Let's see about flipping this. All right. So from space, I've got a little glare right there. Coming in from, we'll have to see. Okay, let's give this a shot. So from space, what's happening is that we know Earth orbits Sun. If we start our new year, say here, then to orbit Sun once, it's kind of wild. We look up at the sun, and of course it looks far away. in 6 months, we'll be over here. So as it orbits, in about one season, we're here, 3 months, another 3 months, another 3 months, and another 3 months. But, hey, how you doing? Can you see? Marcos? You there? We're kind of glitchy.
I can see you, yeah.
Good, good, cool. All right, we'll give this a shot. So Marcus is here. We're going over just some questions, and really, we're great. That helps. Get a telemarketer call. Okay. All right, we got Marcus in the room. Marcus in the house. All right. All right, so we're going over these ideas, and you may have seen them before. Have you seen some of the videos, Marcus?
Yeah, it's a little laggy, but
Yeah, yeah, that's good. See, it's good that you have your video on because you're lagging too. So I don't feel so self-conscious. Yeah, it's Zoom. Okay, so why do we have a calendar? What's going on? Well, Earth orbits once, but the funny thing is that as we go around and we think about day and night, then 365 day and nights, we end up here. Really close, about an arm's length. It'd be about a quarter of your pinky. So it'd be pretty small, but we're still very close. But it takes another 6 hours to get back to where we started our year. So to go around one time takes 365 days and another quarter day. So one orbit takes 365. It's really 0.24. I'll write the correct. So we'll say 365.25 or 365 and a quarter days, and that is 6 hours. Close enough for understanding this. So the point is that when our calendar, if we start New Year's here, our calendar's up, we're not quite back to the same place. We're about a quarter day short. And then another year, we start here, we say Happy New Year here, we come back and we're short, way exaggerated, another 6 hours. Year one, after 1 year, after 2 years, after 3 years, we're short another 6 hours, so 18 hours. And after 4 years, we're short by a full day. And so we add that day as leap year. So it's not exactly correct to say that we have 365 days in a year, because the time to orbit once is a little longer than that 365 days. And the main couple of things that, one of the main things here is to try to connect what it is we see from Earth, watching sun rise and set. And people didn't know why. Why is this happening? To taking a look at it from space, seeing from space and imagining that. So that's year. Anything I can make clearer? You guys can help me improve that if that's not clear. We good? Thumbs up. I got Marcos good. Tiffany good?
I'm good.
Is that easy or hard? What do you guys think? Amanda, what do you think? Easy or hard?
Usually pretty simple.
Pretty simple.
I
Yeah,
got it.
don't overthink it too much, but it's just interesting to orbit once to come back to the same place. In 1 year, we don't quite come back to the same place. Okay, so seen from Earth, chapter 1, chapter 4, seen from space. We're going to build on that, especially with the seasons. All right, let me test out my whiteboard erasing skills. So let's talk about but any questions are okay. Like, I have no idea what you're talking about, or what do you mean by this or that? So let's talk about the day. And then we'll do seasons. No, shouldn't have sprayed that. Let that dry. So a day, of course, means just sunrise, sunset. And so for a day, and we did this in class, I know, but real quickly, we can go from noon to noon. And I'll do a little less detail than I did. I won't redo all the lectures since I think that would take longer and not get to your question. So noon to noon. And we call that 24 hours, which is a solar day. We got sunrise around 6 a.m. We're going to build on this with that moon diagram, which you may have hopefully gone through some. We got 9 a.m. Then we got 12 noon. And then we got 3 p.m. Oops, p.m. 6 p.m. So sunrise is roughly for us now, roughly 6 a.m. Sets roughly 6 p.m. 9 p.m. 12 midnight, 3 a.m., etc. So it's going to be important to be able to do that, especially for the moon phases. So that's what we mean by a day, sunrise, sunset. But we saw from the last discussion of a year, it doesn't actually rise and set at the same time. It changes throughout the year. We know that. But that's good enough for now. From space, what's going on is that Earth spins. And so, why does it? The question becomes, why does the sun rise and set at different times and different places on our horizon? What's happening for a day? So if sun is over here, and sometimes I'll draw sun as being, in reality, way far away. So there's the sunlight. And then draw Earth a little bigger. And then, of course, what's happening is that the sunlight hits Earth, and this is a key point. It's not too bad when you get used to it. Don't overthink it. The sunlight's going to hit that, so whether or not Earth is tilted, and we'll get to that, the side that gets lit is day, and the side in the dark is night. So that's night, and the other part's day. We're going to add a little bit more detail, as you probably know from the seasons. Okay, so then as it spins, this is going to be, I'm going to draw this as a view. We can do it side or top. I'm going to do this as a top view. So that little dot there, which is not doing so well, is going to be the North Pole. And I did grab before I kick this out. So North Pole is right here. And we're going to spin into the light, sunrise, noon, sunset, midnight. Is that okay? You guys? Myra, how's that?
Yeah, that's pretty helpful. I think what's been helping me a lot is the YouTube videos.
Yeah. So should I go? I can go faster so that I can get to your questions. I just don't want to go too fast. So I think the YouTube, yeah, is, there, I'll go through it slowly. So why don't I lay this out and then you guys ask questions or, anything that doesn't make sense. Okay? That sound good?
Yeah, that's fine.
Yeah, okay. So the way I'm going to draw this, even though sun is way out there, is really kind of ridiculous, but we'll exaggerate this. So if I think of myself or someone standing here on Earth, here's our ground, and we'd be tiny, but here we're going to draw it like this as a person. And so to spin once would mean that the person is facing way that direction, directly to the right. So that would be a one spin. And so if I come over here and I realize that, hey, I'm actually orbiting around sun while I spin, but if I spin once, still I've come back to here. So there would be one spin around that way. Now, the tricky thing is, it's very small, spun back around that way once. So that's one spin. So what does a day mean? One spin of Earth is from here to here, but it is a little shorter. And I'll show you this. A little shorter than noon to noon. And you got those details in that YouTube. So what do I mean is shorter than noon to noon? Well, if I imagine, it's a pretty small effect. We're talking 4 minutes. So it's pretty small. But if I take sun and I bring it in real close just to exaggerate this, now I can see that if I was here on Earth, I'd go, sun is high in my sky. This is my east horizon. This is my west, and sun is the highest all day. That would be noon. But over here, I've spun once, and sun isn't high in the sky. It's over here. And so, again, very exaggerated. But to really visualize this, I've got to spin a little bit more. I've got to spin a little bit more over here, and then sun is going to be over my head. And so noon to noon is this, one spin is this, and we're talking only about 4 minutes. So it's a tiny effect, but it helps us to think about these differences. We say, oh, Earth spins once. Well, kind of. This is one spin. This is 24 hours. Is that sort of okay? Any questions about that? Okay with that? You can ace that on the exam. Any questions? Good? Samantha, are you there? You said you couldn't see.
Yeah, I'm here.
Okay, good. How's that feel?
It's good.
Okay. I mean, it's pretty abstract, and it takes a while, but as I say, like anything, you do it a few times. It does start to click. So this is what we watch, rise and set and rise, or noon to noon. Why is that happening? Well, because we're spinning, but there's a little difference between spinning once and going from noon to noon. And so we start building on that. And this lets us understand things a little more deeply, and it lets us have that perspective from space that we don't normally have. And this is what people didn't have for the longest time until we figured out the heliocentric. Good? Erase? All right. So it's not too bad. Again, it's amazing multiple times through. I mean, I was working on something on guitar, so I decided, well, I'm sitting here at home, I might as well. Hey, Chani. And Noah here too. Good, good. Okay, so we're glitching a bit, probably from Zoom being overloaded. What we're doing is going over some ideas that are on the videos. I'm not going as slowly as the YouTube, but seeing if you've got any questions, and I'm recording this too. So although it's probably not going to be a good quality, we're just giving it a shot. We're jumping in, doing the best we can. But if you've got any questions, please stop me and ask me, and I'll try to find another way to make it clear. Does that sound good, Johnny? Can you hear me? Good. Noah, you there? Noah? You're here. Okay, go. Gotcha. Awesome. All right, you guys are getting to be pros. We're all getting to be pros at Zoom. All right, so we've talked about, just went over the difference between what we see for a year, our calendar, sunrise, sunset, a day, sunrise, sunset, seen from Earth versus seen from space, and now a moon cycle real quickly. I'll go through this and make sure you know there's a few little things. So I'll mention things that people get wrong. One thing is that seen from Earth, again, we draw our horizon. This is our ground, and that's our sky. And if you miss some of this, there's a variety of reasons. Don't feel shy about that or embarrassed, because it's pretty abstract. And life is hard to balance, especially now too. So just go for it. So moon is going to rise somewhere and set somewhere. Let me say this, where moon rises and sets and when is kind of tricky, because moon doesn't have a nice, easy orbit. That we'll get to that a little bit. You might have read that moon's orbit is tilted a little bit. So that's a little crazy, but it does rise and set. And so I'll draw a full circle for moon. And so for example, just because this is something I didn't do on the YouTube, so you might take a look at this. When it rises, it's going to look like it's going this way. Comes up, goes ahead. Remember to connect these dots to draw the terminator. And it actually turns over somewhat, which would not be a bad thing to do. Let me do a waxing crescent. Or, I don't know, let's do waxing gibbous just to be different. So I'm going to connect that line. Waxing means the west side is lit. A gibbous means it's mostly lit. So I'm going to go like this. I'm going to go like this. And so on that one night, it'll rise and set as a waxing gibbous. Okay. So we watch this and we see a phase cycle. And if we watch it really carefully, it turns out a phase cycle is actually 29.5 days. We'll use 28 days or 4 weeks usually, but just to be picky for this once, that's what we see from Earth. So we watch it go from new back to new. And that's not so easy to do, really, because new is up there with sun and so on. So it can be a little tricky to do that. Okay, that's what we've seen. Chapter 1, you can draw the phase cycles, waxing for 2 weeks about, waning for 2 weeks about, but not exactly. All right, so from space, any questions there? Good. Oh, okay. So seen from space, what's happening? Well, what's happening to give us these phase cycles is that, and we'll get into gory detail, moon orbits Earth once. And it turns out that for moon to complete an orbit, it takes 27.3 days or I don't really care if you say 27.3 or 27.5 days is easier. I like that because halfway between those two is 28 days. 28 days or 4 weeks. So why are those different? Why isn't it that moon orbiting is the same time as going from new to new? And the reason is because Earth is moving around sun. So let's do that. Then we're done with these ideas. And it also, again, is a big preparation. Got to move that bike. Okay, so if sun is, again, this drawing the scale is incorrect, but we'll do this. Big star out there. And now again, we're going to do a top view. And so a top view means that Earth, we're going to put the North Pole right here, and Earth's going to spin around. Sunlight will hit us. This will be night, that'll be day. We'll spin into the night, sunrise, noon, sunset. And that's North Pole. Again, that point of view, spinning like that. Okay, so then we've got moon in there. So let's throw moon in, and moon here, if we think about this, sunlight's going to hit moon. Again, I'll tell you the number. You don't have to worry about it right now, but sun is 400 times farther away than moon is. 1 AU, 93 million miles. Sunlight will hit here. And so if we look at that, I also threw in my bag before I left this. The side facing sun is lit, but the side facing us, people on Earth would all see on that same day a new moon. Can you guys see that? Noah, can you see it? Just ask different people. Noah, can you see that? You hear? I can see it. Awesome. Okay, so this is a new moon. So what does it mean to go new to new? Well, if it comes over here, you go, oh, that's a full moon. So moon is orbiting. Moon is orbiting roughly, but not exactly, around our equator. And if we were just sitting there, we'd go from new to new in one moon orbit. However, you know that not only are we spinning, we're orbiting, and so exaggerating so that our picture really picks this up. I put Earth over here. I go like this. Then for moon to orbit once, it'd be in line over here again. And here's the part. If I really exaggerate it and put sun here instead of way out there, I've actually got to tilt this. The side facing sun is lit, the other side is dark. So here, I'd see this. That side facing sun is lit, this side is dark. And I didn't want to get into that too much, so let me do this. Because I want to hold off, and I didn't do this in the book purposely. So if Earth comes around here, if moon orbits once, it's here. And all I want you to think about is, in order to have a new moon, moon's got to be in line with or conjunction with sun. And here, moon has orbits once from here to here, but moon is not in line with sun, so it's not yet new. In fact, anyone know what phase that would be if it's just about to be new? What's the phase before it's new? There's a good exam question. What's the phase of moon before it's new? You got it? Think about it. This is the kind of the depth you want. What's the phase of moon before it's new?
Is it a waning crescent?
Yes. It's a waning crescent because, right, before being not lit, it's going to be a bit lit. So, and then you know it's got to be getting less lit because you're going to go from a bit lit to not lit. So that means you're going to wane, and a bit lit's a crescent. Yay! It's a waning crescent. So again, super exaggerated here. I need moon to move around to be in line, but while we do that, Earth moves over here, moon moves over here. There's a lot of motions, and right there, boom, it's in line. Now it's new. So new to new takes 29.5 days. One orbit takes 27, you could say 0.5. I mean, who really cares? 27.3, it's fine if you're doing calculation, but getting a sense. Okay? What do you think? Any questions? Good so far? So make sure you can answer questions like that. You know, what's the phase just before it's new? And as we discussed, and I think it was Jessica maybe that brought it up. Do I see Jessica? I don't see Jessica anymore, right? That on the exam, if we're doing online exam, I probably won't be able to have you draw this and figure that out yet, but you should be able to answer questions about it. Okay, this leads us into the question of why do we have seasons? And let me go over that kind of quickly, and then you guys jump in and ask questions, anything that's not clear, and any suggestions on how to make this serve you better. Okay. And again, just interrupt me, don't, this is for you, so it's not an interruption. All right, give this a shot. So the simple answer, you should be able to answer that. Why do we have seasons? That is, you could say, again, seen from Earth, which is chapter 1, so that's why we did that. And it was confusing to people at first. If you're getting used to it, that's awesome. And you're seeing, because we don't go out and watch sunrise and sunset every day. It would be kind of cool, but right. So we know this whole gig, and we know it's going to rise at different places over here. But our question is why? June, July, August, September. Directly east, directly west. October, November, December. We see that our days are getting shorter. Sun is lower, so the shadows are longer. Right now, we've gone December, January, February, March. March 19th, actually 11:49 p.m., so it's kind of March 20th, very close, really. Technically, that happened. March equinox, about 12 hours a day, 12 hours a night, equal night. March, April, May, and June. So it's going to change. But why? Now we have a little longer day than we do night. You can really start to feel it. And that's going to continue. But again, we're going, why does this happen? So let me write the answers. Seen from space or spaceship. So here's an important thing to think about is Earth spins around its geographic North Pole, South Pole axis, which is these two, North Pole, South Pole. And we can think of that axis like the handle. But you know it also orbits the sun, but it isn't straight up. It's tilted. Perhaps from a large collision. I have kind of another idea about that too that is interesting, but we won't worry about that. So the key is the reason that we have seasons is Earth's North Pole, South Pole, what I call the spin axis, is tilted. In fact, it's tilted 23.5 degrees. That's 90 degrees. We'll see Uranus is tilted that way. That would be 45 degrees. And half of that would actually be 22.5 degrees, so about that. Think of roughly half of 45. So it's tilted a little. So let's see what that does. So if sun is here, Earth isn't straight up like this, it's tilted this way. But this is a really important point. If sun is my fist and Earth is tilted this direction, it stays tilted that way, to the right. Tilted to the right, tilted to the right, tilted to the right, tilted to the right. It does wobble a little bit. That's what changed your zodiac signs. But that one full wobble takes 26,000 years, so it's a very small effect. Okay, so how is it, is the next question, how is it that the tilt makes that happen? Now we're doing, okay. And again, jump in any place that's like fuzzy, aside from Zoom.
So I have a question.
Yeah.
You said that we're at 23.5 degrees?
Yeah.
Okay, and then you said Uranus is at 90 degrees?
Yeah.
So it'd be like this?
Yeah.
Or no, or like this. Sorry.
Yeah. No. So straight up would be like this. Uranus is like, it's not quite 90, but it's pretty close to 90 degrees. So it orbits, it's weird. It's really weird. And we'll talk about, yeah, and we'll look at other worlds too, but we'll just give you enough information so you can kind of keep up with modern understanding. So most of our planets have a little bit of a tilt. They can have a little or a lot. We're tilted, not 45, but about half of 45. If it wasn't for that tilt, we wouldn't have. This is totally weird. I think the more you actually get stuff, you go, wait a minute. Yeah, it's strange. And we'll spend a very short time on Uranus and Neptune, but just get you introduced to the cool stuff. Good, thanks. I appreciate that. Anybody else? All right. Let's see why it is that Earth being tilted makes that happen and makes it so that we're warmer here and cooler here. Now, let me do this. Added value for those of you that are here and listening, and this is kind of cool. So let's take a note here. If you watch this, in the northern hemisphere, let's do it this way. I'm gonna do this. I'll erase this and just want to see if anybody's trying to contact me. No, okay. So the answer for why we have seasons is because of our tilt. Let's do this. Well, in the northern hemisphere versus the southern hemisphere, let's take a look at the two solstices. So let's say around June 21. In the north, we call that, summer solstice. But in the south, so for us in the north, that day, we have this red line. In the southern hemisphere, they see the blue line. That's what's happening for them. It's flipped. Around December 20th or 21st, sun follows that blue line, and we have the winter solstice. And on that same day in the south, sun follows the red line, or the summer solstice. So it's flipped. And this reinforces the fact that the reason for season is not that we're closer to sun in the summer. In fact, we're closest to sun. Let's throw that down. Recall from Kepler's first law, we're closest to sun around, you could say January 1st, that's good enough. And then farthest around July 4th, which is kind of fun. So we don't have summer because we're closest to sun. In fact, for us, it's winter. For them, it is sun. Okay. Question? That is really wonky. Can you hear my voice okay? Does my voice come through? You guys? Tiffany?
You're kind of glitching.
You're still lagging a little bit.
Yeah.
Yeah.
Does it make it impossible to get anything from it, or is it still valuable full review?
It's on and off.
On and off.
Yeah, we could hear you. It just goes on and off. And sometimes when we're trying to see the board, it just gets very pixelated because it's glitching a lot.
Yeah.
Yeah.
Yeah. Should I go
Is it less
slower?
glitchy if I turn off my video?
Oh, try that. Yeah. All right. Yeah, maybe if you turn off. All right, so Marcos, you're turned off, right? Yeah. All right, you're frozen in time, Marcos.
Yeah.
Good, there you are. Oh, cute. Okay. All right. Well, let's give this a shot. So we're asking why we have seasons. And again, you know, you can certainly go through life without knowing, but it does tie us to Earth, and we're trying to expand our awareness about all that, and build a point of view where, like Marco said, well, that's really weird that Uranus is tilted over. And as we think about our world, Earth, and our solar system and the planets in it, and then other solar systems, planets going around other stars, we're now on the journey to see if there's life elsewhere and what that would be like. So we have a deeper understanding of all that and how big and crazy it all is. We know that this happens not because we're closer to sun for summer, because we're closest around January, which is summer in the southern hemisphere, and not because we're farther, because we're just a little bit closer, a little bit farther. Makes a little difference. It's because of the tilt. So going over the tilt, see if you got any questions on that. Do that. There's two things that happen. Really three, but I elected to not get into that too much, although I think I will in the next book. But I can tell you the third if you're interested. Okay, so what does tilt do for us? It does two main things, 2 + 1. It's got dry. How many degrees? Anybody? How many degrees is Earth tilted? $90.
23.5 degrees.
Yeah. So half of 90 is 45. Half of that is 22.5. So that's close enough. You'll figure it out. Close to that's 23.5 degrees. Half of 45 degrees. So does two things. It changes the concentration of sunlight. Huh. Interesting. And it changes how long the day is. And now that you got that kind of really drilled in, that path of the sun, it changes how long our day is. Length or time of day versus night. And so we want to be able to see why that happens. So first you should know that. You can answer that, okay. What does Earth's tilt do? Well, it changes the concentration of light and it changes the length of day. Concentration of light's kind of easy. You know, I go through details on the video, but if you think about it, it's just like, as I mentioned, catching air or wind as you put your hand out of a moving car. Here if I tilt my surface, so tilting a surface, if I tilt the surface, I can catch more wind, or if I tilt it away, I catch less wind. I tilt it towards, I catch more wind. I tilt away, I catch less wind. So too, I can think of that as warming light. If I tilt my surface towards the light, I'll get more warming. And if I tilt my surface away, I get less warming. I think I put her somewhere. I thought I brought her. Okay, so that's really all it is. If you tilt your surface towards the sun or light, you'll get more direct warming, like catching some more rays. If you tilt it away, then less light will go through or hit your surface, and it's less warming. So that's all that is in a way. If you guys are the sun, then if I tilt towards you, this part's going to get more direct sunlight warming, but the south gets less. As I tilt away, more concentrated light, more warming, tilted towards, sorry, and tilting away, less concentrated light, less warming. If north is tilted away from sun, less warming or concentration. But if north is tilted away, south is tilted towards. More warming, less warming, more warming. Question? You got a question or no? Is that okay?
Can you go over that one more time, please?
Yeah, and I want to make a point here too. And this is by my doing this, that could be confusing. Let me do it this way. I'm going to put sun here, and I'm more than happy to go over things until you get this. So we know that Earth is tilted, and let me draw a side view now of Earth, ridiculously close because sun is 100 times wider than Earth, but that's okay. Again, just to get the point. And what I'm going to do is tilt Earth. So, and we're getting to this. Forget about Earth's tilt right now. When the sunlight hits Earth, however Earth is tilted, this is my night. And this is my day. When you're in the sunlight, it's day. When you're out, it's night. And as I go about 6 months, right, we did that whole year thing, so that builds that sunlight is going to come from here, and forget about tilt right now. Whatever side is facing sun is lit. The other side is not lit, so it's night. There's the terminator. Shade the dark side. I got day here. We're building up to the next thing. Now I'm going to show it tilted. And this is, so catch this part. Just realize, and you don't see this normally. This is what gives us what we see. But what's happening is that Earth is tilted. And if it's tilted to the right, it stays tilted to the right. So I'm kind of mixing things. So I'm going to do the tilt in here. And I'm going to throw North Pole in here and South Pole here. I'm not going to worry about being exactly 23 and a half. I'm going to go through the center, and this is the line that it spins around. So there's North Pole. And then come around here, and North Pole will be over now in the night, still tilted this same way. Earth spins around. And so that means that our equator, I'm jumping way ahead, but kind of try this together. If our North Pole, South Pole tilts, so does our equator. If our North Pole, South Pole tilts, so does our equator. They're perpendicular to each other. L. Okay, so here's the point. Now, if you live here, say San Francisco, let's draw you super tall, then your surface is tilted towards the sun. You're catching more rays. But if you live in the southern hemisphere, south of the equator, can you see how you would be tilted away from the sun? Tilted towards the sun, I get more warming. But if this is a light bulb or a fire, and I tilt my hand like that, I'm not going to warm it very much. Here I get more warming. Here I get less warming. It's flipped, just like the seasons. So too, if you're over here and it's tilted this way, even in the daytime, your ground is not facing the sun. It's tilted away. Again, like trying to catch wind out of a moving car. I tilt towards the wind, I catch more wind. Tilt away, I catch less wind. Tilt towards the fire, I catch more fire or warmth. Tilt away, less. So here, your surface, think of it as a hand, is not getting warmed very much. However, the folks in the southern hemisphere, they're spinning around like this. You would spin around like this, spin around like this. Think of that as their hand. They're getting the blue. Southern hemisphere folks are getting a lot of warming because the South Pole is tilted towards the sun. North Pole, not much warming because the North Pole is tilted away. Did that make sense, Myra?
Yeah, that was helpful.
Okay, good. Well, then you were helpful because I need you guys. That's really good. Is it glitching as much?
Yeah, it's still a little glitchy, but we could hear you fine, so that's good.
Okay, cool. Thanks, guys. Appreciate it. Okay, so that's really all it is. You know, if you take, and I talk about this, if you take light and you use a magnifying glass, if you make the light more concentrated, it's going to be more warming. If you spread it out, it's less warming. But the idea is really that if you're tilted towards the sun, here the North Pole is tilted towards, you're going to get more warming, just like your hand. But if north tilts towards, south tilts away, less warming, more warming. North tilts away, and you're going to spin like that. So this is a hard one for people to see. Remember that you're going to spin along a latitude line parallel to the equator. A latitude line parallel to the equator, you're going to spin like this. Here's San Francisco, you're going to spin like that around. And they're going to spin a latitude line parallel to the equator. They're going to be tilted towards, getting nice warming around January. This would be for us and for them. This would be like, sorry. Mixing my, this would be actually the solstice. So this would be December 21. Winter for us, summer for them. Our summer solstice is their winter solstice, like June 21. And that brings us to the last little point. And again, going over and over, it does get easier. It's crazy how that works. Concentration, okay? Good. Who's here? Camilla's here. All right. Hey, Camilla. Do you have your, you can either type in or you can put your mic on and hear us. I'm recording this. For what it's worth, I get to see how glitchy it is. I wonder if the recording comes out as glitchy as the, maybe not. Maybe not, we'll see. It's coming straight through me, we'll see. You there, Camilla? see if I guess online, I guess you kind of get to know people, but now at least I got to meet you guys for about half a semester almost. So I have a sense of you. Okay, so again, like a lot of things, it's doable. It'll make sense. We good here? I'll take that as a yes. There's Camilla. Yay. Hey, Camilla. All right, welcome to my my garage. Figured I'd do it in here. I might do it from campus. Well, I'll probably do these Zooms from here. So what we're doing, sorry guys, we'll just recap. I'm gonna do the actual lectures. I might go to campus if it's not irresponsible, because it's gonna be better than this. But one way or another, I'll do fill in the lectures, put those on YouTube, and then here we'll talk about it. I'll also have discussions for discussion boards, and you guys can share ideas and so on. I think we can get it done. So, but I want to be there for you guys to ask questions. Also, while we're at that, if you email me, then we can have a Zoom conference. You can show me what you're doing or whatever if you have questions. It might be, there's a chance, as skeptical as I am, I mean, I think it's really nice that we're all in the same room. But there are ways that this could help you learn better and faster. So let's see if we can't find the positive in all this. Okay, so we discussed the two meanings for year, day, and month, just to kind of review that, see if there's any questions. I'm back. I think I'm back. Wow. Yeah, so I got cut off there for a minute. The video and audio are questionable. Zoom is probably on overload. I'm going to guess that's what it is. Anyway, I think there's a way that we can work to get your questions answered and move forward. So hopefully we can do that. But feel free, anything about the class. Let's see if we can get this done. And yeah, so we were talking about how Earth's tilt gives us the seasons two ways. I might mention really quick a third way, and I'm curious, any feedback on this would be good. I don't want to overload, but there is a third way. So I'll just mention this. I can't hold you responsible for it because it's not in the book and on the other videos. But it's kind of interesting. So I teeter. Remember that there's the side view, North Pole, South Pole, equator, and we spin around at some latitude along a line like that. If we tilt that way, then as we go around sun, we stay tilted that way. There's a top view, which we've used sometimes, especially moon phases. And then we spin this way. But I'm doing the side view. There's a layer of atmosphere, which is chapter 5. And that's probably a good way for me to segue into that, but I don't have that yet. The layer of our atmosphere would be about as thin as a piece of paper, thinner, around this. Yet when the sunlight comes through our atmosphere, we're going to see the sunlight, some of it gets absorbed and blocked. Let's make it ridiculously large. Here's our atmosphere. Hopefully it's above our head. Ridiculous. When the sunlight comes here, it's gone through less atmosphere. If you're on the horizon, sunlight goes through more atmosphere. And so not only do you get more direct light warming your hand with the sun, less direct, not very good to warm your hand, but actually more sunlight has been absorbed. And so you're actually even getting less light that way too. I don't put in that atmosphere Anybody have a thought about that? Do you like knowing that, or should I leave it out? You can type or you can say. Any thoughts? Does that make sense that when you're tilted towards sun, sunlight's going to go through less atmosphere, and here it's going to go through more? What do you think? Camilla, does that make sense? What do you think? Anybody? Can you hear me? Thumbs up. Oh, you know what? I can't hear you. I see your mouth moving. Maybe can you click your little microphone that says mute? And it's weird because it doesn't. No, I can't hear you now. And I don't even have my, let's see over here. So that reset. That's annoying. Okay, let me see.
Do you hear me now?
Yes, I hear you and see you.
Okay.
Cool. So what do you guys think?
Okay.
Does this make sense that if you're tilted towards sun, the sunlight would go through less atmosphere? If you're tilted away, the sunlight would go through more atmosphere? Does that picture?
Yeah, it makes sense.
And then that means more of it would be blocked. Maybe I'll tie that in with, I'm not going to ask you though that. So that's kind of a third reason that often isn't discussed. It seems it's actually, as I say, our atmosphere is quite thin, but it's enough of a difference to make a difference. In fact, it's enough of a difference to make it so that at sunrise and sunset, as we cross the terminator, a lot of the blue light is absorbed or scattered around. And so at sunrise and sunset, we see what's left over, namely the reds and oranges and yellows on the horizon. But maybe I'll do that as an extra thing at the end of the chapter, but not now. Okay, anyway, sorry, I was using you guys to give me some ideas on that. Okay, all we want, if you're tilted towards sun, your hand's gonna, like a fire right there, you're gonna get more warming, you know that, warm my hand. And what you gotta get is how this picture is the North Pole, South Pole tilted, Northern Hemisphere tilted towards, but the Southern Hemisphere is tilted away. That's not a very good way to warm your hand. 6 months later, the North is tilted away, less concentration, but the South is tilted towards, maintaining that same tilt. Okay, I'll probably beat that to death, but if you got any questions, you can always talk about it. Number 2 is that we're going to have longer days in the Northern Hemisphere here and shorter days in the Southern on June 21st-ish. Longest day, shortest day. Longest day, longest night. And here, it's going to be the reverse. And let's see how we do that. And I know you have the video, but this is the chance for you just to stop me and help me make that clear. So the sizes and distances are ridiculous, but they get the idea across. Let's do this again. Okay. Draw Earth, nice and big. I'm gonna draw it nice and big so I can really see it. And Earth 6 months later. So let's say this is like I'll make this June 21. And I'll make this December 20th or 21. Let's just say December, 6 months later. Sun is lighting the side of Earth facing it. Forget about tilt. This is the confusing thing. So we're going to draw the terminator and shade the dark side. That's a light bulb. The side facing sun gets lit. Draw this a little more clearly. This is not the North Pole, South Pole. Side facing sun is lit. This side is not lit. This is the terminator. This is the night side. When you cross the terminator, sunrise and sunset. This is the day side. Just jump in. Just interrupt me, please, if anything doesn't make sense. Got any question? And believe me, it's new, so, well, what do you mean by that? Okay. And then when Earth is on the other side of sun, literally looking up at sun, we're going to be on the other side. Hard to figure this stuff out on our own. It's going to light this side, so I've got this. And so the left side is dark here. The left side is lit here. Just thinking about where the light's coming from. Again, terminator, night, day. And now I add in. So if Earth was not tilted, it'd be like that. And it'd really kind of be a drag because we wouldn't even have seasons. And so we're going to look at other worlds that do they have seasons or not have seasons. And the way I'm going to draw it is, I'm going to say the Earth is tilted this way. Again, not a top view, side view, North Pole, South Pole. Keeping that tilt, keep the North Pole tilted that way and that way. The equator perpendicular to this line. And that's what we need to draw in there. So let's throw in, do it this way, our North Pole, half of 45 degrees. I'll probably exaggerate a little bit here. There's my North Pole. And as it come around, North Pole will be over here. That way. Oops, I want to change that color. Here's South Pole on the night side. This is on the night side, so I'm going to change it. Doesn't matter, but South Pole. Ah. North Pole. Now the South Pole is in the light, so I'll say South Pole. And the spin axis, I will draw green through the center. Earth spins around. We talked about that a little bit. Night, day, but it's tilted. Spin axis, Earth spins around just like the globe spinning. Don't be confused by that. Terminator. So I draw a line perpendicular. That confuses a lot of people. Just make it across like that. This is the equator. I keep that the same over here, perpendicular to this line and that line. Again, the equator. And we're almost there. And remember that latitudes are also called parallels. And those are parallel to the equator. So if I draw a north latitude like this, I'm going to try to grab a little night and day. That would be a northern latitude, and a southern latitude would be like that. And we're going to spin this way, just standing there. And if we spin that way, you're going to see that we have a very short night, a short amount of time in the light. We will cross here, sun will rise, and then we'll have a long day. It's June 21st. And so in the northern hemisphere, we call that the summer solstice. We have the longest day, maybe 14 hours of day, and the shortest night, maybe 9 hours a night, depending on what your latitude is. In fact, if you go all the way up here, you're going to have 24 hours of day for a little while, depending on how far north you are. So that is there. In the southern hemisphere, however, they're going to have a long night. Then you cross sunrise, and they're going to have a very short day. We'll pull all this together here in a second. Southern hemi, winter solstice on the same calendar day. And you know the gig, I won't write it all out. But we've got a few things happening. We're in the sunlight longer, and we're tilted towards the sun, getting more concentrated light. They're in the sunlight, day shorter, and they're tilted away. And additionally, the atmosphere thing will go with that. So those two things change how much warming we get. Now there's other factors like air and water currents and seasonal things, but these are the primary things giving us summer, and then they get winter. Also, you might notice, because you're tilted this way, sun is going to be higher in your sky, like that one path we drew. Here you're tilted away, and sun is going to be near your horizon. It's going to be that winter path. So on that day, just to reinforce, on June 21st, the southern hemisphere sees that, low in the sky, short day, the sun is coming in at an angle, less concentrated light, get long shadows, dramatic, nice. And now we're approaching summer, sun high in the sky, longer day, sun coming down at more direct an angle, and that's seasons. Do it over here, and the key is draw so that you grab some day and night. Draw a line parallel to the equator. There's a north latitude, short day, long night. South latitude, parallel to the equator, long day, short night, giving the flipped solstices. Who knew there was so much to seasons? Solstice, equinox, solstice, equinox. Questions? Oh wow, we finished like class and everything.
Do you hear me, Professor?
I do.
Well, what happened the Earth tilt during fall and the spring? The tilt is going to change situation?
So it always stays this way. Now watch. So by tilting towards, I get more direct light and I stay in the light longer, right? If I tilt towards, that warms my hand more, I tilt away less. If I tilt, I stay tilted this way. So it's not like I'm tilting the other way. I don't go like this. I stay that way. And over here, north is tilted away from sun. Here, because I've gone to the other side. tilted towards, tilted away. So in between, I'm neither tilted towards sun nor away from sun. I'm tilted like this. And because of this half of Earth along that line is going to be night, and that half will be day. And when I spin, I get 12 hours of night and 12 hours a day. So the equinox for us, summer solstice, winter solstice. Equinox, winter solstice, summer solstice. And then I go around the other side, equinox. So on the equinox, we're neither tilted towards sun nor away, but tilted along the line of the orbit, which is harder to draw, really. So this is June 21st, then 3 months we're over here, 3 months we're here, 3 months we're back on the other side, like that. Does that make sense?
Mm-hmm. But that doesn't change any, I mean, the tilt of the Earth doesn't change so much for during the other season.
No, it
No.
stays this way. It's just that when we're at different positions, we're either tilted towards, now we're not tilted towards, now we're tilted away.
Mhm.
And so we do wobble, kind of like if you spin a top or something, it kind of wobbles a little bit, but it takes 26,000 years about to wobble. So it's a very slow effect. That little wobble as we spin, that little kind of like that, but it's very slow, is the reason if you're born in July 2,000 years ago, sun was in front of the region of Cancer, if you're following the Greek, Roman, and actually Middle Eastern work set that up even before. So if you were born in July 2,000 years ago, sun was in front of the region we call Cancer, and now it's in front of the region we call Gemini. And that's because of this little effect, you know, kind of crazy, and no wonder people didn't figure it out until we got all this. So being heliocentric really tells us a lot, but it's really outside of the realm of our experience. I mean, we can experience that, but crazy. So in the north, summer solstice, summer leads into fall, equinox, winter solstice, spring equinox, summer, and then flipped, everything flipped, winter, spring, summer, fall for the southern hemisphere. Got it?
Yes. Okay.
Yeah, you guys can master this. And again, repetition is the key. We've gone a little longer, but this is office hours, so we're working it out. I hope it serves you guys, and you can learn it and have some fun with it, because it's kind of cool, and maybe better than just class where it's a big group. Sean is here. Sean is here, and Turner is here. Turner, remind me, Turner, who Sean is. Sean, are you there? Is it Sean Prophet, right? That's correct. Prophet, you should have. And Turner, and if you want, you could click your little audio thing, the little microphone on the left side down there. Sean, Angel, yes, right. I knew that. Angel, Turner, cool. So, and I think that's a pretty good amount. I recorded this. Zoom is overloaded, and so it's glitchy. And we'll make the best of it. I'll put up, and I tried to give you a break. I realized I was emailing you a lot, and I thought, well, there's a lot going on, and I didn't want to add more stress. So balance that. But now we're back in the game. I'll set up discussion boards for each section so you guys can answer each other's questions maybe and just see what you're thinking. And the hard thing about discussion board is, of course, you don't have a whiteboard. But then when we meet at our regular class times, I can answer questions. I could do it kind of quickly because I'll do it more cleanly and slowly on the YouTube. And so we'll have the discussion boards. We'll see if you guys can do the the HIs and submit them online. So we'll all just mess with this and learn we'll get a degree in Zoom too. So we'll look at that. We'll meet at our regular times. And again, I'll be able to answer questions. I've got to take roll. And so people need to at least show up. It may or may not be as useful to you, but I need to know that you're in the game and it's going okay. Cool, Angel. I see that you haven't been able to figure out how to connect your audio. And so you could try connecting audio down on your screen. There's a little microphone kind of icon. It's a little confusing. If there's a line through it, then you don't have audio on. And if you click it, you might be able to get audio. But the chat room works as well, and you can click the chat and you can click the video. I don't know if you guys having video on makes it more glitchy, but Marco had it on. I don't know that it helped that he turned it off. It's nice to see you guys, actually. So that's how we're proceeding. One time, I got kicked out of the room, and then I just had to wait, and then it reconnected me. I mean, my Wi-Fi signal is strong here, but I think it's the system.
Okay, I have a question. How can we send the handout to you by the picture, or do we need that? Or
I think if you can see if you can scan it and submit it to Canvas, although I'm not entirely sure. So if you guys figure that out, let me know. Well, I'll play with that a little bit too and see how we do that.
Actually, I don't have any scan, but I can take a picture and send to you.
Right,
It's
taking
okay.
a picture. I mean, that's a scan for me. That works. So yeah, we'll start with that. I know that there are some schools, K through 12 schools, that have places where people can drop off work.
Oh, okay.
But that's kind of a pain for you guys to have to do that. So I mean, maybe if we did drop off a bunch of work and.
But anyway, it's the risk that people thought that their paper.
I think it's real. I mean, they say that this week our numbers are going to explode, and that's the way it was in Italy. And I hope it's not true, but the people that are in that have medical conditions and certainly elderly, we're going to lose a lot of them, and and that's sad. I know I have some folks that are older in my life, and so we want to, and apparently we just want to reduce the spread, because if you have 10,000 people coming over to your house all at once, it's a problem. If they do it little by little, you can feed them or whatever. So that's, I think, what we're trying to achieve. But yeah, so we'll work it out. We'll have patience, and I hope that you guys, I want to give you enough support in learning this and clarity about what you need to learn. And hopefully it's.
When is your, excuse me,
That's okay.
When is your next class? I mean, then this class, the online Zoom.
So we'll do it Mondays and Wednesdays, 9:35 to 11.
Okay, the same schedule. So
And
we
we'll
have.
just do it the same schedule. We'll meet. Cool. Thanks, Samantha. You too. All right. Thanks for coming in. Yeah. So we can meet, and then I've got a few other classes and a lab trying to coordinate all this stuff, but I think we can get it done.
Right.
Yeah, and I think you guys see too. I mean, it's a pretty small group that showed up, and I know that some might not be able to handle it, but we'll hopefully get used to it. But it is amazing how something that seems completely confusing and unclear, how you start catching on. So hopefully in these meetings we can just go over the fine points, or what do you mean by that? And hopefully people feel free also to ask that question, like, I don't even know what that picture means, whatever it is.
Can I ask you something?
Yeah.
Could you please say to us what pages do you want to talk if we cannot see exactly what you write in the board, so we can see in the book actually, so we find out that.
Yeah, I think YouTube is a good place, and there are places in the book that I've written. So this is section 4.3.
Yeah.
Chapter 4, yeah.
420.
420.
Page 420.
Yeah.
Yeah.
And so, and this I walked you through in an exercise, and then we do it. So page 427 shows all this. I say all the steps, and then of course I do it in more detail on the YouTube, or more slowly, I should say. And then we get into moon phases on 429. And there I actually do show the picture step by step, kind of work you up to it. So I don't think, I'm completely open to whatever people want to use this time for, but it seems like if I go kind of quick and then you stop me at confusing parts, that would serve best. And I think that if you watch the video, and I'll send out an email too as we get going, like, okay, make sure you've reviewed the videos on moon phases, for example. And then I did a video on eclipse, which is very short. Once you get the moon phases, eclipses are pretty quick and short. And then I've got to do a video on the last section on the tidal effect, which is pretty cool. I'm really not happy that we can't do that together in class, because there's some fun stuff I can do.
Exactly. I have seen actually your all video in YouTube.
Okay.
Yeah, it was very useful. Thank you very much.
Good.
And we try our best actually.
Yeah.
Thank you very much anyway.
Yeah, but hopefully, the combination of, I think, going round and around, like reading, video, asking questions, hopefully that'll, and again, it'll be interesting to see you guys' opinion. It could be even better. I don't know, because we could hit some points. I don't know. It's nice. I think there's value in people coming together. And
Exactly.
Yeah, but
this is the part of life.
yes, yeah. Now, not good to come together. Yeah. I hope people are, you see people on spring breaks and going to beaches and ignoring all this.
Right.
It's really not responsible to.
Thanks, technology.
Yeah, yeah, I know. I mean, could you imagine even 10 years ago, we couldn't do this. So now this is pretty cool.
But although has a little technology has had a little boring, something like coronavirus international problem.
Yeah,
But thanks anyway.
yeah, awesome, great. Well, thanks. We got a group in there, and thank you, Chandni, and everybody's checking out. So feel free to email me any questions too, and I'll send another email. You know, I don't want to bombard you guys too much or overload you, but I think once we get up and rolling, it'll be clear. And I'll show you, I'll put up some discussion boards right now, and people get used to the structure, I think. Are you doing this in
Thank
other classes? Are you doing this in other classes? Are you using
Excuse me?
Are you using Zoom in another class or?
No, only this class. I have math class, but actually I don't have Zoom, this program for math class. I try to follow YouTube and then schedule, so my teacher gave me paper already. So it's not easy, but yeah, I try my best.
Yeah.
Yeah, but this is very good. This is very good. I thank you. And I still remember my first time I used this program Zoom Room for.
Yeah, it's not bad, right? It's
Yeah, I think
Yeah.
it's good.
That's pretty good. I had to learn how to set up a meeting. I mean, I'd done it for some meetings, but yeah, I kind of feel like it brings back a little normalcy to connect with students because it was really weird there. It's good that we have spring break coming so that everybody can.
Yeah, we don't have any schedule for spring break, right?
No,
Is
but I will be.
normal spring.
Yeah, I'll be around. All the ski resorts are closed, so I can't go anywhere. So yeah. So I'll be available, and we'll just see how it rolls. Like you say, it's a good, especially for the younger students. You know, it can be a challenge to learn how to roll with things, and life is like bumpy like that. So hopefully they can make it.
Yeah, and we have this class on Wednesday, and then we are off for 1 week for a spring break.
Yeah, but I will be available for emails. The discussion board can keep going, and we can have Zoom office hours. So hopefully there'll be a lot of resources, and I can help you guys get this stuff and have some fun.
Thank
No
you.
star
Thank you
party.
very much. Thank you. I appreciate it. Thank you. Have a great day, and thank you for this class. And I'm happy to see you again.
I know. I'm really happy to see you too. Actually, it's great.
Thank you. Another opportunity for me. Thank you.
Okay. All right. Cheers. See you
Thank you. Have a great day.
You too. Bye.